Today we are going to start solving equations. And the one thing I always want you to remember, and I'm going to write this right at the top and star it, if you are stuck. So these are just my little notes to you. If you are stuck, change the form. Because now you know two different forms. And what I mean by that, if the problem is an exponential form and you're stuck and you don't know what to do, try to change it to a logarithm. And if the problem is in logarithmic form and you're stuck and you don't know what to do, try changing it to an exponent. That's just something you can see if it might help you. So if you are stuck, change the form. Change the form. Because we're always thinking, what can we do if we don't know what to do? And sometimes that might help. So let's look at this first problem. So now I have that's in exponential form. And one of the first things I always want to look at is there a way I can easily make these bases the same? And so I have a 25 and a 10. And maybe I could do that if I do all sorts of things with the powers, but I mean, there's no easy way I can make, I'm thinking 5 squared is 25, and there's no easy way I can get this base to be a 5. So now at this point, let me try to change the form. So now I'm going to have log, and my base will be 10. And now I'm going to have a 25, and it equals x minus 1. And why this is helpful is it changes the place of my variable. So where a variable before was in the place of an exponent, now it changes the place of it. So if I was in class, I would be holding up my hand on the screen and saying, so we have x minus 1. How can we get x alone? And you'd tell me, well, we'd add 1 to both sides. So we would add 1 to both sides for here as well. I'm going to say plus 1 and plus 1. And so now I'm going to put the 1 up in front and say 1 plus log with a base of 10, 25 equals x. I wrote the 1 in front because sometimes when I write it behind, like in the other way with log base 10, 25 plus 1 like that, that's not the same as a 26. They mean something different. We can't combine them like that. Now the next thing I'm going to do is I'm noticing I have a base of 10. That's a common logarithm. I'm going to say 1 plus log of 25 equals x. We have just solved for x, and this is an exact answer. So this would be exact. That's an equal sign. If you want to convert this to a decimal and have an approximate answer, and it just depends with your problem, what you're looking for, that's when you would put it in your calculator. I do want you to try that as well, just to get used to putting these in your calculator. And then find the key with a common logarithm, and you would get x, and we would round, is approximately 2.398. So that would be the approximate answer for this problem. Okay. Now we're going to do B. This one is a natural log. First thing I'm going to do for the natural log for now is I'm going to rewrite this with the base. So anytime you see ln, that's the same thing as log with a base of e, and I have this 2x plus 3, and then equals 4. So at this point, I can't separate that log or the natural log with a 2x plus 3. There's no way, like I can't divide those. They're not multiplication by each other. They're connected together. The only thing I can do is I can change the form. So I can say e to the 4th power equals 2x plus 3. So now at this point, to solve for x, I subtract 3, e to the 4th power minus 3 equals 2x, and now I can divide by 2. So I would say x equals e to the fourth minus 3 divided by 2. That would be my exact answer. And then if you wanted your approximate answer, that would go in your calculator. And for approximate, that would be x equals 25.799. That would be approximate. And actually, it's not equals. It's approximately. Okay, what I would like you to do now is pause these and do the 2 practice problems. Okay, for the first practice problem, this is a common logarithm. So that means it has a base of 10. And as you're still getting used to these, I would copy the problem and add in that base of 10. And then say 3x minus 2 equals 2. I would do that before you convert to your exponential form. And remember to convert. Their base is 10, your exponent is 2, and it all equals 3x minus 2. So base to the exponent, and the 3x minus 2 would be your answer. From here, we would solve this. This would give us 100 equals 3x minus 2. And now we have 102 equals 3x, and x would equal 34. And for B, if our variable is in the place of the exponent, we have an e on the left side and 8 on the right side. There's no way I can make those bases the same, so I'm going to go and convert to a logarithm. So I'll have log with a base of e. Now I'm going to put the 8 next, and equals x plus 2. And now at this point, I'm noticing whenever I have a base of e, that will be the natural log. So the abbreviation for that is ln instead of log with a base of e. Then an 8 equals x plus 2. And now to solve for x, we subtract the 2 on both sides. I like to write it out in front because it's not going to be a 6, and sometimes I do see that mistake happen. So negative 2 plus ln 8 will equal x. That will be your exact answer, which, to be honest, is the way I'd prefer them. Just like that. Okay, for the next one, for C, we do have the bases the same for this. So when the bases are the same, you can set the exponents equal to each other. We have negative x squared equals x squared minus 2. So now we solve this just like we would an equation. We're going to get the x squareds on the same side. So it would have negative 2x squared equals negative 2. And now I'm going to like to make it all positive. 2x squared equaling 2. I divide everything by 2. I would have x squared equals 1. And then x equals plus and minus 1. And then for this last one, there's a lot going on here. How we want to start this one first is, I'm just going to copy it to make it a little bit bigger. If you don't know what to do, we can always copy the problem. 13 equals 41. The first thing we want to do is subtract 13 from both sides, because what we're trying to do is isolate the base with the exponent. So I'm going to subtract 13 from both sides, and we're going to end up with 8 And then we still have 4 to the 6 minus 2x power. And now that's going to equal 28. Now, we can't distribute because you can't multiply the 8 times the 4 because the 4 has an exponent attached. But what I can do is divide each side by 8. That will simplify the left side and leave us with 4 to the 6 minus 2x power still. And then here, 28, we can't divide that by 8, but we can reduce the fraction, and that will reduce to 7/2. Okay, so now we have a variable within an exponent, and we're at a point where we may feel stuck, and that's one of the first things we said. When you feel stuck, if we don't know what to do, we can switch the form. So we can have a logarithm with a base of 4, and now we're going to treat this just like we did all the others when we converted the form. I'm going to write the 7/2 next, and it's going to equal 6 minus 2x. We can subtract 6 from both sides. I'm going to still write it in front. Negative 6 plus log with a base of 4, 7/2 equals negative 2x. And the last step, if we're solving for a variable, we're going to divide by 2. So all of this we can divide by 2, or I can put it, well, I'll divide by 2 just to show you. Or negative 2, sorry, negative 2. And then we'll have x equals, I'm going to put it in parentheses, negative 6 plus log base 4 of 7/2. We could leave it if what I have before, or multiply it times the negative 1/2. They're equivalent. Either one is fine. That would be an exact answer on that one. If you wanted to make this first part a 3 and then bring the negative 1/2 to the second, log base 4 of 7/2, that's fine as well. Okay, that would be okay to do. Okay, E. Okay, first thing I'm going to start this next problem, the first thing I'm noticing is we have a variable in the denominator, and we want to deal with that. We want to figure out a way to get that variable out of the denominator. So I am going to multiply both sides by 1 plus e to the negative x power. And whatever we do to one side of the equation, we can have to do to the other, e to the negative x power, and then that's okay. These will cancel out, and then we're left with 400 equals 350 times 1 plus e to the negative x power, which is better because at least we don't have a variable in our denominator anymore. So then I could distribute, but I know I want to isolate x. I want to get x alone. So instead of doing that, I'm going to divide each side by 350 because we are going to have to do that anyway. And then 350 will cancel out. And now I'm going to reduce 400 over 350. That will give me 8/7 equals 1 plus e to the negative x. Subtract 1 from both sides. Now I'll have 8/7 minus 1 is 1/7 equals e to the negative x power. So now I'm at the point where I can't really go any further, so I'm going to change my form. So I have an exponent, I'm going to change it to a logarithm. With a log with a base of e, 1/7 going to equal negative x. And anytime we have a logarithm with a base of e, I can rewrite that as natural log of 1/7 equals negative x. And just any other way I would, if I had a negative x and I wanted to make it a positive x, I would multiply or divide by -1. Same thing here. It's like multiplying or dividing by -1. And I would just have negative ln of, oops, sorry, the negative does not go there, 1/7 equals x. And that would be my final answer for this one. Okay, last problem we are going to try today. This problem almost looks like a quadratic, and if you look carefully at it, it can actually be factored. Because if you look at it, we can, in the first part of the factors, try out e to the x power. And if you think about your properties of exponents, e to the x times e to the x would give us e to the 2x. Because when we multiply exponents, we add. And then if we think, are there two numbers that multiply to 6 that will add to -5? And that'll be a -2 and a -3. And then will that work for our middle terms? And -2 e to the x. And then if we add that to a -3 e to the x, we get -5 e to the x. So this is factorable. We set that equal to 0. So after we've factored, we split up each of the factors, set equal to 0, e to the x minus 2 equals 0, e to the x minus 3 equals 0, and we solve each equation. We have e to the x minus 2 equals 0. That'll give us e to the x equals 2, and that'll be log with a base of e, 2 equals x, and now I'm starting to notice more when I have a base of e, that's our natural log, of 2 equals x. I'm going to do the same thing for our other factor and have e to the x will equal 3, and that will be log with base of e, 3 equals x. Another natural log of 3 equals x. So we have two answers for this.